In this exercise, we're going to be working on a file renaming utility. So the first few versions of this are going to be basically just a script, something we can just run and, take all of our files, rename them, do whatever we need to do. We're just going to sort of hard code a lot of things into it. And I really suggest doing this because it's really tempting to go try to build an application or utility or a tool that solves all these major needs you have. But usually if you go build the hard-coded, the simple versions and just sort of see how it works, you'll start to really understand more about what you're trying to solve. But on top of that, you'll also get an idea of whether or not that's even possible. So you'll see with this one that there's a couple things we're going to try to keep track of that maybe you're going to be kind of tricky to do with a universal version of this. So maybe it just doesn't make sense to do that. Now I do have the bonus on this. Is to make that universal one, and you can decide which features you want to support, which you don't, if you choose to do that. I don't know if I'm actually going to code that one on these videos, but I will try to code most of the other things, and you'll get to see how you can use regular expressions and some of the other stuff. So let me take a step back and explain to you what we're trying to do. So I've got this here, so let me zoom in. I've got the exercise details here where I talk about, you're going to start off with a folder directory, something like this. Now, you can use whatever folder you want, but this is one that I've included in the repository to make it a little bit easier to test your code. And with this folder directory, your goal is to navigate through all the files in this directory and to find ones that match a certain pattern. And if they do match that pattern, you want to then rename them. So for instance, let's say we have this birthday001.txt. Maybe you want to rename this to be something more like this Christmas 1 of 100 type thing. And, so you want to come through here and you want to rename all these to this be 1 of maybe 4, and this be 2 of 4, 3 of 4, and 4 of 4. So you want to do something along those lines where you're renaming things. Now you'll see here that inside of this nested directory, we start at 8, we have 9 and 10. So maybe you wanted to make those 8 of 10, 9 of 10, 10 of 10. You can see here that very clearly we've already got this weird case of, do we want to know, how many of the files that match that pattern there are, or do we want to know, what the largest number we've seen is? How do we dictate what that of part is? Or maybe we just want to say, just n space 1 or n space 8, n space 9, n space 10, or maybe we want to rebase them. I don't know. The idea here is just to get you experience writing a program that will walk through a folder's files and then can do some sort of operation on them. So you'll see here that I linked to the path.filepath package here. What we're going to be using here is both the walk and the walk function type to basically create code that will walk a file path and allow us to perform some sort of action on that. So you'll probably want to read the docs here and see how that works. I'm going to start off writing code that focuses more on taking this file name, matching it, to pull out the data that we care about, and then returning the new file name. But once you've got that done, you're probably going to want to do something like use the path.filepath package to learn how to walk all the files. And you'll need to decide if you want to be recursive or if you just want to walk the top level directory, things like that. And then on top of that, you'll probably want to look at the os.exec package or the os package's rename function. So when you want to rename files, there's different ways to do it. I say the os.exec package is one option because you could create a command that just calls the move command in your terminal. I don't necessarily recommend this, but if you want to practice using commands of some sort, you can do that. The other option is this os.rename function, which is part of the os package. And let me see if I can click it real quick. Basically, this is going to allow you to rename a file with an old path and a new path. And then finally, you might want to look into regular expressions. So when we start, a lot of these we're going to look at ways to sort of split up the files and try to parse the data out the data we care about with different techniques. But eventually, regular expressions might be the best way to do it. That's kind of up to you, so you can just decide what you want to do. I'm going to start without them because, one, I just think it's interesting to check out some of these other ways to do it, just so you can get an idea of what it's like. But two, because regular expressions can be kind of tricky, especially when you're just learning them. There's the old saying that I think I might have even mentioned in another video that, you have one problem, you introduce a regular expression, now you have two problems, because it's very easy to make a regular expression that, matches something you didn't expect, or, doesn't match an input you expected it to match. So they can be tricky at times. So that's about it. just to recap, the goal of this is to write a program that just goes through this directory and rename some files based on whatever criteria you set. I have files here to sort of make it easier, but you decide what makes sense. Maybe you have some images or something like that in your or on your computer that you really want to rename. For instance, if you had a digital camera and took a bunch of photos, you'll often get file names like DSC with a big number at the end, and maybe you want to rename these all to be, Valentine's Day, and just number them all 1, 2, 3, 4, 5. So it's really up to you as to how you do it. I'm just going to sort of, work through this with a couple of different examples to give you some ideas, and you can go from there. So the first thing I want to do in this exercise is I want to just basically figure out how we're going to match file names. So I know that there's going to be some way. So if I come over here and I look, if I look at this file path package and I look at some of the stuff, I know there's going to be some way for me to get file names. So what I really just want to focus on is, all right, once I have that, what can I do to sort of match these things? Because I think that's going to really shape how the rest of my program works, and what sort of things I use. So what I'm going to do is I'm just going to go ahead and go to main.go, open up some main.go file. We'll just do package main, and I'm going to write a function that we're just going to call match for the time being. And I'm going to assume we're going to take in something like a file name, just string, and that's probably all we're going to take. I don't really know. And then we're going to return a new string, which is, if we match it to something and we want to rename it with something else, that's what that'll be. Otherwise, we're going to return an error, and the error is going to be something like, hey, we didn't match, or whatever, basically it's going to tell us that we didn't get a match for some reason. So for now, I'll just return pretty much nothing. And I want to start with a file name. So I'm going to do, file name is going to be, let's do birthday 001.txt. Okay, so what I want to do with this file name is I'm going to try to convert it into, let's say, actually, let's just change this entirely. We're going to uppercase every word in the string. So whatever this is, birthday. And right now there's no underscores or anything like that, but maybe I'll add some examples to show that later. So we're going to say birthday, and then we're going to do something like 1 of 4.txt. So we're not going to do any parentheses like we are here. We're just going to go ahead and just do something like this, or maybe we'll put a dash here. So I think that's a reasonable output. Again, there's not really any set outputs in this exercise because it really depends on the person, what they want, all sorts of things. I just want you to sort of see how to walk a file path and just get some experience writing some little scripts like this that you might want to use. Okay, so let me go ahead and pull this up too. So we've got this going. Now we want to go ahead and figure out what is our match. So we're going to say new name, error : equals match with the file name. And if the error is not equal to nil, we'll print something like no match. I think that's fine for the time being. Otherwise, we're going to print out, we want to return or os.exit. We're just going to exit with 0 for the time being because it's not really an error if we don't match. I mean, I guess it could be since we know we're trying to, so we could just do something like this. os.exit 1, and then we're going to do format.println. Technically, I just hate that pronunciation. All right, we'll print out the new name otherwise. All right, so let's go ahead and go run main.go. And we get an empty string because that's what this is returning. So now we want to go ahead and do some matching here. And I'll just put a little comment here like match returns the new file name or an error if the file name didn't match our pattern. I'm not going to really bother defining what that pattern is right now or anything because, again, this is going to change. And this is, as I'm writing this, just so you know the context, this is meant to be a one-off script. It's meant to be something that, I quickly run. Let's say I had 200 images in a directory. I wanted to rename them for some reason. This is what I'm going to write real quick to do that. So I'm trying to show you this with that sort of context in mind, that we don't need a super robust program, and we don't even need to necessarily use best programming practices if we're just trying to get this done real quick. Because this is going to be throwaway code. So, it doesn't really make sense to make it maintainable when we're not going to maintain it. Now, if you're trying to practice, maybe you want to, and that's fine. I should go ahead and preface it with that. There are some reasons like, just practice, but for now, I'm just going to go ahead and keep this going. All right. The next thing we want to do is take our file name and we want to try to split it up. So we know looking at this birthday thing, we want 3 pieces. We're going to want something like birthday. We're going to want something like the number. And I don't think we don't technically need these leading zeros, but we don't want to get rid of them because we never really know. This could be 10, this could be 11, this could be 101. We don't really know. So we can't just go deleting things. I think it's better just to get a string like this and then parse it as an integer to turn it into an actual number. So I think that makes the most sense. And then the last thing we're going to want is the extension. So something like txt, or if it's a JPEG or PNG, whatever it ends up being. So those 3 parts are probably what we want to pull out. So let's see, how can we do this with the file name? One of the ways we can do it is we could use, let me go ahead and look for it, strings split Golang. And if I can find it. All right, so split. It's going to split a slice into all substrings separated by a specific separator. There's an example, sweet. So if you see here, if you run this, we get, what was the string that we had? Oh, ABC with commas, and if we split it based on the commas, we get a string like this. Just the same down here, a man, a plan, a canal, Panama. If you split it by a space, you get this. And what's important here to look at in both of these first cases is that it returns the string split by those things, but it doesn't actually return the thing you're splitting by. So, if we're using the commas or separator, the results don't have commas in them. That's gone. That becomes a separator in the slice that we get back. So going back here, I'm going to pause real quick. All right, sorry about that. I've made the mistake of recording lots of video with the wrong mic before, so I was just trying to check and verify that I was using the right setup here. Now that we can get back into coding this, let me go ahead and move this recording monitor. So we want to go ahead and split this based on, different pieces. So I think what we're going to do is we'll probably split it based on this underscore and based on this period. And there's always a possibility that file names don't really match that, or maybe it's going to match things we didn't want it to match. So we're probably going to want to put a little bit of checks in there. And I don't think this has to be too crazy. Normally we can look at our directories like this and we can say, are any files going to match this that we don't expect? What's the end result going to be? And you can also add something like a dry run so you can really see what's going to happen. And I'll show you that towards the end of this. Okay, so what I'm going to do is I'm going to say pieces is going to be strings.split. And split takes in the string, so file name, then the separator. So I'm going to put period as the separator first. So this should separate our string into something like birthday underscore 001 and then an extension. Assuming there's more than one piece, that's not what we want. Assuming there was maybe a period in this name, that could be wrong. So what we're going to do then is we're going to say we only want the extension is going to be pieces pieces, the length of pieces -1. And this means we're getting the very last piece. That should be the extension, whatever's after the very last period. And then we're going to take the rest of pieces, strings.join. We're going to take the rest of pieces, so 0 to length of pieces -1. And we're going to join them with a period. So if we did happen to split this into birth, period, day, into 3 different pieces, we're going to go ahead and join these 2 back together with that period in the middle. So we kind of undo that unnecessary split. Okay, so we want to go ahead and say file name is going to be equal to this. So we're going to go ahead and destroy that original file name we had, but I think that's okay. All right, so now we want to go ahead and split file name based on the underscore. And I think it's a safe assumption to say that in this case, we're expecting the very last thing after, if say there's multiple underscores, we only care about the last bit. That's going to be the number or the count of, which one we're currently on. So I'm going to say that pieces is equal to file name or strings.split. File name, and we're going to split on the underscore this time. So now we should have name is going to be strings.join pieces 0 colon length of pieces minus 1. And we'll merge these with the underscore. And then the number, comma error is going to be a string conversion dot, what are we looking for? A to I. So ASCII to integer, and we're going to pass in pieces, length of pieces, minus 1. Then finally, we're going to say if there's an error. Usually what this is going to mean is that something went wrong. The number we got back that we expected to be a number wasn't. So I think the best way to handle this is to do something like return empty string and return error %s didn't match our pattern. And then for this, we probably do want the original file name here. So I'm going to go ahead and change this part here to be temp, just tmp. Then down here, I'm going to make sure we use temp instead of the original file name. And then we want to go ahead and do file name. Otherwise, we need to, at this point, we need to return the matched pattern. So I'm going to go ahead and return sprintf, and we're going to do %s. So this is going to be the name part. What we're trying to do, I remember, oh, this is the format we want. So we want to do %s space dash space %d of, you see here the second part, we don't actually have a number for it. So I'm going to go ahead up here and say total int, and just say that's a piece of information that we probably need passed in here. Or for now, we could just say, something like this. So we'll get rid of that of part, and then we can come back to it later. Dot, and then %s for the extension. So this is going to be name, number, extension. And then nil for the error. All right, so assuming that all worked, we need to go up here and change this. I'm going to get rid of this total because we decided not to use that for the time being. Let's see how this works. Okay, so we forgot to make this capital like we wanted here. And you'll see that we also have the period in there, which I had sort of stuck in there just to show you that this does indeed work. And I can put an underscore in there, and yep, that's still working too. So what I'm going to do here is I'm going to strings dot, I think there's a title, pass a name, and I'm going to come here real quick and say strings title Golang, just so you can see what it does. All right, copy of string s with all Unicode letters that begin words mapped to their title case. And there's a bug here, but I'm not going to really worry about that right now. All right, Her Royal Highness. So it's going to capitalize every single letter. If that's not what we wanted, we want to do something a little bit different, but I think that's fine for what we're doing here. Save it, run it, and that looks to be correct. It looks like that it's counting a period as a separator. It's not counting the underscore, but I don't think that's a terrible assumption at this point. I'm going to go ahead and rename this to birthday because that's really what we wanted. Okay. So we've got a match function. We also know that if we wanted to add an account here, we could do something like total int. We could pass in, if we figured out the number ahead of time. So that's going to imply that we kind of need to know that ahead of time, but that makes sense anyway. There's no real way to, do 1 of 4 unless we know there's 4 things. So we'd have to figure that out first. But since we've got 1 of 4 here, we could also do %d of %d, and we'll put total here and go run this, and we're getting birthday 1 of 4.txt. So I think it's a good stopping point for now. The next video, we're going to look at how to actually get this data. So how to get the total count, and how to, go through and get these file names. And you'll also see that we can reuse this match function to actually figure out if something matches our pattern moving forward with a lot of our code. So, maybe it makes sense just to show you that quickly. Let's do... Actually, I'm just going to change this now. We'll just do birthday x01, and you'll see that this should give us a no match. So we're getting exit status 1. Looks like we're coming in here. So knowing that, moving forward, we should be able to go ahead and write some code that will look through all of our files, try to figure out which ones match it, and then once we know they do match it, we can come back through and we can start to, try to actually get counts and things like that. And along the way, we'll see some potential errors, but we'll work from those and sort of move on. Okay, so the next thing we're doing is looking at how to get all the files in a directory. So we can basically try to figure out which ones match the pattern we're looking for, so we can get both a total count of how many files we have, but also so we know which files to rename. So let's go ahead and, where are we at here? So there's two ways to do this. I mentioned the walk, filepath.walk, which is a way to walk a tree rooted in some specific root directory, and then we're going to just go through navigating them all. This will be the recursive one. So if you look at, if you're looking at this, it should go ahead and recursively look at all the different subdirectories, and unless you tell it to skip one specifically. So what we're going to do is eventually use this, but first I want to show you a simpler way to do it. I say simpler, it's not really that much simpler, but a way just to sort of list all the files in a directory. So that is the readdir. So if you look at this, basically what you do is you call ioutil.readdir, pass it in a directory, and this is going to be relative to wherever you're executing your program, unless you use an absolute path, obviously. And it should give you this slice of files that we can go ahead, and these are all file infos. So if we open the OS package, we can look at this and see that file info is an interface that has name, size, mode, mod time, isdir, and sys. So basically, isdir is the one thing it's going to tell us if it's a directory or not. So if it's a directory, we don't really want to do anything with it. And then the next thing we're going to care about is the name. This is how we're going to figure out what the name of the file is so that we can, go ahead and change it. So let's go ahead and see how that looks. The easiest way, in my opinion, is just to comment this all out. And then to do files, equals ioutil.readdir. And we're going to do the sample directory. So we're going to assume that we're reading this from somewhere else. And I don't actually know what this returns. So it returns a slice and an error. So I'll go ahead and do it this way. If the error is not equal to nil, we'll just panic with it. And then we're going to say for each file in the range of files, if file.isdir, print out something like this, else we're going to say, let's do, and we'll call match file.name. And this is going to return both an error. I'm just going to go ahead and put a number here for now. This is going to return both an error and a new file name. So we need to do this, something like this, and we'll do. All right. So all I want to do right now is just sort of figure out the results from this. So this is all we're doing. So let's go run main.go. And you're going to see here that we've got these matches, and we've got these, which are errors that are saying that we did not match the pattern. And then we've got the dir nested, but we don't do anything with it right now. So that appears to be, roughly what we were expecting. And you'll see here that we can actually just pass in an arbitrary number here, 0 or whatever. Clearly it's not the correct number, but it seems to be working. So what we can actually do here is we can keep track of a count. So we can say count is going to start at 0. And then here we can do something like if error equals nil, count plus plus, get rid of this directory, and we don't really need that. I don't want to run this just yet. So then once we've iterated over this whole thing, we're going to go ahead and say, actually, let's do something different. Let's do, so we don't have a path. That's another thing to keep in mind. It's going to be relative to this, but we don't have that yet. So when we're going to be doing, so normally we'd probably run something like a dry run. So I'm going to assume we're doing a dry run right now, and then we'll add it so this actually works here in a second. So I'm going to say path, or age path is going to be, it's going to come from something like, here's the path. So that's going to be this dot sample part. And then the next part is going to be slash and then the file name. And then the new path is going to be something like, same idea, basically doing something like this. All right. I don't know where we went there. So what I want to do here is I want to, every time I find something inside of here that, we need to go, we know it's a match, we want to do something with it, we're going to increase count, but we're also going to add it to this toChange slice. So it's going to be var toChange is going to be slice of strings. We'll say toRename. So these are the ones we want to rename. So in here, we're going to say toRename is going to equal append toRename. And then we're going to do this part here. And we're going to say this. So I'm actually going to grab this, come up here and say dir is going to be this. Place both of those at the directory. So now I can just replace it with a single variable. And then the second part is going to be the file.name. And that should add it to this slice. Okay. So the next thing we're going to do is we're going to go ahead and say for each file or for each original path in the range of toRename, we want to go ahead and figure out what is the new name of this file. There shouldn't be any slashes in this, but just in case, instead of doing this, you might want to do something like file name, string, and now that I think about it, I could have done file name, which is just, let me go ahead and grab all these. File name can be, I think it's usually acceptable to do it this way these days. All right, so file name, string, and then the next part is going to be full path, or we'll just do path string. So inside of here, we're going to do struct. We should probably name this struct just to go ahead and type. Something like this. So then down here, I'm going to say we want a rename. We're going to say path is going to be this part here. And then the file name is going to be file.name. Something like that, I think is what we want to do. All right. So for the original and toRename, I'm coming back down here. What I want to do here is I want to figure out what the new name is going to be and then just print it out so we see what the dry one looks like. So we're going to say move %s %s. So this is where we're just going to tell it what we're planning on doing. So I'm planning on doing something like bridge.path is what we're originally starting with. And then the next thing we're going to pass it into is going to be, we'll do new path is, or sorry, not new file name is going to, comma error is going to be match bridge.file name and the count. So that's the count that we got up here. Not sure why it jumped like that, but whatever. Okay, so now that we know that what the count is, we can actually use it here, and we're going to say if the error is not equal to nil, we'll panic with the error for now. It's probably not a good idea long term, but for the time being, I think that's fine. And then finally, we're going to go ahead and say this part, new path, is sprintf %s dir new file name. And I should also mention that this sprintf probably isn't, it's not going to work on every OS, so I'm going to have to get to that here in a second. So let me just get this working, and then we'll go look at that. I want printf, put a new line at the end, run this. All right, so we're going to move this sample birthday001.txt to sample birthday104.txt. So this looks to be about what we want it to be. So what I meant before when I said that the slashes probably aren't going to work is in different operating systems, the direction of the slash changes. I think Windows uses backslash, and like Linux-y type things will tend to use the /. So I think there's a way. Let's see. So this is the Unixy version. You're seeing here that it's doing this. I don't know. I don't recall if it'll get rid of fix these slashes or what, but basically what we can do, it looks like it might, based on this last example. But what I'm just going to go ahead and do is I'm going to say filepath.join dir new file name. And this actually just reads a little bit better anyway, so that's fine. Filepath.join dir file.name. And you also notice that if I just stuck the file names into rename, I'm actually going to do that. I'm just going to make this a string slice, because I don't actually need all this other stuff. I can figure that all out later. So to rename is going to append file.name. And then down here, what I'm going to say is orig path is going to be filepath.join dir and orig.name. I think it's file name is what I put here. No? I think this needs to be orig path then. What did I call it? Oh, it's just orig at this point. So this should probably just for consistency be orig file name. And I only say that because I've got new file name in here. I think it's just easier to read if you're using a more consistent naming scheme. All right, so now we go run this. Same results on my computer. Well, I guess technically it's starting at the // but that's fine. But if you're running on a Windows computer or something like that, you will probably see different results now. So here is clearly one way of going through and figuring out all the different things that we want to do. So now let's go ahead and see if it works. And I'm going to have, since this is all in Git, I should be able to just, get rid of, undo the changes. So that's why I'm okay with doing this right now. I know I have all these files here in Git, but just remember if you're running it on your own computer on real files, keep that in mind. There's a small chance you might move files around that you didn't want to, or maybe you could potentially lose files. I'm not really sure how you would, but you might. Okay, so I want the os.rename. Pass an old path and new path, and you get an error. So OS specific restrictions may apply when old path and new path are in different directories. We're not doing that. If there's an error, likely of the type link error. So we'll just go ahead and give it a go. Rename. So we're going to do old or orig path and new path. If the error is not equal to nil, panic. And I'm actually going to keep this printf because I want to, and I already have the error defined, so I don't need to do the colon equals. I'm going to keep this printf so that if there is an error, I see where it happened. All right, so let's go run this and come back here, and you'll see that in my file listing here, all of these files have been renamed. And if I actually go to the terminal and go git status, you'll see that these have all been renamed. And if I actually git add, if I add the whole sample directory, you'll see that it's showing you a rename in Git history here. So it's actually reading it as a rename. We just moved the files. It looks like it was what we expected to happen. Now all these files are empty, so I guess it just luckily matches them correctly. At least I think they're all empty. But if they're unique files, you'd be seeing something a little bit different. And there we go with that. And sorry. Okay, so that's it with this. I'm going to uncommit these changes. I'm just going to go ahead and stash most of them. But aside from that, well, actually, I can just show that to you. That's fine. I don't know how much of you use Git that much, but we can do git admin.go, git commit.m, finish part 2, listing and moving files, and we'll say renaming files. Non-recursively. And normally I'd probably want a little bit nicer commit message than this, but I think it's fine since I explained everything over the video. And I'm just going to add everything and then git stash. And that should have, yep, it reverted all my changes there. So you can see that, well, these are all empty again, but they're back to the way they were. Okay, so I think that's good for the first version. What we're going to look at in the next 2 videos is 1, making this work recursively. Do we want to do anything else? We might look at some other things. Maybe we'll do a couple different patterns, look at some different ways to do this. But I do want to do a video with regex, so I'll probably do one of these with regular expressions and show you how we can match that as well in case you want to try to use that to create a more generic version of this that might work in many directories. But I think that's mostly going to be it. This is a relatively quick exercise, but it's one that I find can be very practical. My wife gets a lot of photos. She's a photographer, so having things like this that I can quickly just help her do tasks like that can sometimes be really handy. In this video, we're going to use the filepath.walk function, which I'm going to close this example. You can see here that it expects a walk function. If we come down here to the walk function, we can see what it is. Basically, it's a function that accepts in a path, which will be the current path to the file you're looking at, I believe. Info, which is info about that specific file. And then an error if it had an error opening the file or something along those lines. I think if it has a directory that can't get into, it'll give you an error here as well. And then if you read the docs here, I believe it basically says that if you return any error other than the skip dir error, this right here, this special value, it will basically stop the walk function that you're running here. This whole walk thing throughout the entire tree will stop. And if you return the skip dir one, it'll basically just skip that directory. So the way this roughly works, if we look at this example here, is you pass in a directory, so something like this, and then you pass it in this function, which is often going to be a closure. And then inside of this function, you essentially just tell it what you want to do. And this function is going to be called for every single file in that tree. So if we come back to our code here, if we called it with the sample directory, it would call that function that we pass in for birthday 001, birthday 002, birthday 003, in all of these different files, meaning that we can then use it to check out all the files, even recursively, and decide which ones we want to rename, which ones we want to move, things like that. So you can see here that if we're looking at this os dot, where's it at? It's up here somewhere. ioutil.readdir. When we do this, we're only getting all of the files in a specific directory. So if we wanted to make this recursive, we'd have to write our own code that, if something was a directory right here, inside of this if block, we'd have to put something like ioutil.readdir. We'd have to figure out what all files are inside that directory. And again, we'd have to recursively keep on going through this. So we can do it. We can write our own recursive function that does that. But one of the easier ways to handle it is just to simply use this filepath.walk, which will then walk that entire tree for us. Now, if you read the docs here, there are a couple things that talk about how walk will always run in the same order. I don't remember if it sorts all the files based on, their entire lexical path. And that's the order I think that's the order that you end up looking at them in. So as a result, it's a little bit slow for really, really big directories. There are a couple third-party packages out there that will do the same thing, but they're a little bit faster, but they'll also sometimes have less information, or they're not as deterministic in the order they do. So you need to decide what makes sense for you. I think for what we're doing, this is fine. And when I say it's a little bit inefficient or a little bit slower, I'm not talking like, oh, this takes days to run. It's more like, instead of running in 1,000 milliseconds for a really massive directory, you maybe run in 1,500 milliseconds. So, we're not talking anything incredibly complex in that regard, at least from what I've seen in actual benchmarks, but it will be a little bit slower. Okay, so we're going to go ahead and look at how to do that here. Let me go ahead and just delete all of this. And I'm going to go ahead and just try to just comment this all out because I'm probably going to want to use some of this. Okay, So we're going to have to count first. That means that we're probably going to need to run this filepath.walk twice. The first one just to count the number of files that match something. And then the second time is to actually, basically the second time is going to be to go through and actually rename things. And I'm going to mention that this is going to be a little bit weird in the sense that we can't just count everything that matches. So you see here that these ends are going to, they're going to get counted as something that matches. So that's probably not going to make much sense. Just the same, if you're looking at these birthday ones, it's not going to make as much sense. So you kind of got to figure out what makes sense for you. I think for this first version, I'm just going to get rid of the count. And then the second version, it's not that it's impossible, but you basically have to keep track of this first. You have to figure out which folder you're in. So we're in the sample folder. And you have to figure out this first part, so you can keep them all separate. Because if we move these end files into this non-nested folder, we want to keep the counts of those two separate. So you're going to have to keep track of whatever comes before the count as well. And it ends up adding a lot of complexity that I don't think is really worth exploring right this second when we're trying to see how filepath.walk works. So we're going to get rid of this count, this total part, and we're going to just get rid of the of part, and we'll get rid of it here. And that should fix that part. So now we're going to do filepath.walk. The root is going to be the dir that we pass in, and then we need a function, which is going to be, if we come back here, it's going to look at this definition. And I actually really wish that I had, let me see something real quick. Okay, I don't have that enabled. I'm working on a PR for VS Code that actually expands that into a closure for you, but I apparently did not, I don't have it set up right now to run in this, in this local editor. Okay, so we have this function. What are we going to do inside of here? Well, the first thing I think we're going to do is we're just going to print out let's print out the path, and then we'll print out, what is this, info dot is dir, and then we'll return nil. And we're just going to see how this works. So we'll go run main.go. And you're going to see here that we've got birthday, 0, all those. We've got the Christmas ones. Then we've got the nested folder. And you'll see here that this is a directory. So we are going to get directories called with this. And that's when you would basically tell it to skip the directory if you wanted to. So what we could do here is if info.isdir, we could return filepath.skipdir. Otherwise, we're going to return no. And now if we run this, you'll see that it did that with the sample. Sorry, we're going to do and path is equal to, what was the path up here? Sample/nested. So now if we run this, you're going to see that we get to nested. We see that it's it is a directory. We see that the directory matches the string that we have, so we skip it. And we actually don't need this /, so I'm just going to get rid of it right now. Now, if we run that, you'll see that this ends up being a little bit more consistent with what we've been seeing for all the other directories. But we don't actually want this right now because, as I said, we want to make this recursive. Or I think I said it. If not, we do want to make this recursive. That's one of the big reasons why we're using this. Okay, so the next thing we're going to do is we're going to keep a list of var to rename. It's going to be a slice of strings. And we're going to go ahead and add, this time I think it actually needs to be a struct. So I'm going to go ahead and say type, let's call this rename. Does that make sense? We'll just call it a type file, struct. We'll use our own local file type, and we'll give it a path, which is a string, and a name, which is a string. Those are the only two things I think we really care about. All right, so this is going to be a slice of our file type. And then inside of here, we're going to say if match info.name, and we're going to go ahead and say underscore comma error colon equals match. Error is not equal to nil. And okay, so here's the interesting thing. You remember earlier we had to go ahead and keep track of all these so that we could, actually get an accurate count. Well, in this case, we don't really need to do it just yet because we're not actually, we're not actually doing the counts anymore. So we could just go ahead and use the values here to rename things. But what I'm going to do for now is just go ahead and add it just like we were. And then once we add it later, if we want to add the counting aspect to it, it won't be too much harder to do that. So what I'm going to do here is say to rename equals append to rename file. And the file we're going to add is going to have a name of info.name. And it's going to have a path of path. We also are going to want to add something like if info.isdir return nil. And I'm going to go ahead and just put this down below that. So the reason I'm doing this, I'm going to get rid of this print line too. The reason I'm doing this is because anytime we're in a directory, we know we're not going to rename a directory. That's just not what we're doing with this program. So we can just go ahead and immediately exit when that's the case. We don't want to return an error because we do want it to go down into that directory, but we don't really want to do anything beyond that. So if it's not a directory, that means down here that it's a file. So we're going to go ahead and if it matches, we're going to add it to our list of things that we want to rename, and then we're going to return. So then at the very end, we should be able to print, we could do, I think, %q. We'll do this with to rename. And you'll see that that's not perfect. Let me go ahead and do for each f in the range of to rename. Let me go ahead and print it this way. All right, so we've got Christmas is supposed to be renamed. These are all supposed to be renamed. And that means we have an issue. So if you look up here, what's actually happening is I made a bug. Whenever I put this, what I meant to say was if the error is equal to nil, that means we have a match, and that's when I want to add it. Otherwise, I was doing the opposite. And this is one of the reasons why doing a dry run like this, where you actually get to see what you're going to do, is very helpful. So save this, rerun it. So we got the birthday ones and we've got the end ones. Okay, so now we can actually come down here, and I think it's this section. Uncomment this. So we can say for each file and to rename. I'm just going to keep this as, or actually I got to do this orig. So for each of these, we're going to say that var n, and n's going to stand for new here, and it's going to be a file. And then I'm going to say n.path is equal to, what do we want down here? It's going to be the new file name with the directory. So we can't do that yet. We want to do n.name is equal to this part here. So I'm going to do var error n.name comma error equals match. And here we're going to pass in orig dot name, and there's no count anymore. If the error is not equal to nil, I think for now we're just going to log it. So we'll just print line orig dot path error dot error, and we'll put something like error at the start. So that'll just let us know what went wrong, but it's not going to actually stop our program right now. And then we're going to do n.path is equal to filepath.join with the original directory, which I think is still, yes, sample, and then the n.name. And then finally, we're going to go ahead and print out orig.path, n.path. And I'm not calling this new, by the way, because new is a keyword in Go that's used for other stuff. So it just seemed a little bit weird to use that. And then down here, os.name, orig.path, and n.path. And then finally, if there is an error, again, I'm just going to go ahead and print this. Error matching, and this will say error renaming. Okay, so now we can go ahead and give this a go. And you'll see here that it looks like we moved all the birthdays and we moved all the nested files, and we capitalized the ends in the birthdays. So it looks like this worked correctly. So what I'm going to do now is I'm going to add everything, and I'm going to reset head. I didn't mean reset to be capital. I'm going to stash this all. I didn't mean to stash everything. All right, so let's go ahead, and these are all not there. just going to go ahead and add main.go, get reset, head, everything in sample. And with that, just because I think it's going to be easier, I'm just going to commit my main.go. So implemented the walk function. So now if I look at my status, you'll see that all I have is these files. And there's other ways to do this, I'm certain, but I'm just drawing a blank right now, and I don't want to mess around with Git while I'm on this video. Okay, so I've still got my main.go here. It all appears to be working. We've got this part, it's working recursively. It's going through that all. I think the next thing I want to add is counting. So, we actually want to try to keep track of the counting. And I told you before that we would try to do something with it. So we need to decide what is the most important thing with the counting. Well, we can't just keep the first part of these files, like this birthday part, because there could be a birthday here, and then there could be another birthday inside of here. In fact, I could actually just copy 2 of these, paste them inside of here, and we can see here now that if we counted that way, we would have an issue. So I'm going to leave them there just to make sure that we do it correctly. So what we probably want to do is we're going to take the entire path minus everything that's not unique. So, the parts that are, that we're going to be counting with. So maybe what makes sense is to keep a path of something like sample/nested/birthday, and another path of something like sample/birthday. Things like this that is unique enough that we should be able to go from it. And it might even make sense to use the extension as well, just in case there's a birthday JPEG and a birthday TXT file. So knowing that, we'll probably do something along this line. So that means that we need to come down to our match function and it needs to change. Or maybe it doesn't need to change, but maybe we need to get something else from it. So I'm going to change our match function to, instead of just returning a string, I think what I'm going to return, well, we know that we have the base, we've got the count, and then we've got the extension. So we could just go ahead and make this something like base extension, and then we could add a third variable, which is going to be the index int, and we have an error, which is an error. This makes our return type kind of long though, which I don't love. So maybe what it makes sense is to make a type match result. And this is going to have something like the base, which is a string, the index, which is an integer, and then the extension, which is a string. So I've got the match result here, and now we can change all of this to return a match result. And I'm actually going to make this a pointer, specifically just because I want to be able to return nil. There's no real other reason for that. All right, so now if I get scrolled down, we can see here that we've got these pieces. And here we're going to go ahead and return nil with that. Otherwise, if we have a match, we're going to return match result. Need this to be a pointer, so I'm going to put the and in front of it. And this is going to be something like name. Is that what we call that? Yep. And I'm actually going to titleize this already because there's no real reason not to. It'll still be, unique if, for all of our file paths, or I suspect it will be. On the off chance, we need it to be anyway, because even if it's not, we could potentially have files conflicting with their names. So I think that's a fine assumption for the time being. Again, this is kind of a one-off script, so we can make a little bit of assumptions like that. All right, so we've got that, then we've got number, and then we've got extension. Then we're going to put nil as our error and save that and make sure that's working. That appears to be working there, but you can see up here that it's clearly not. So what we're going to do is now we're going to go ahead and create a map, which is going to be something like, we'll call it string for the, we're going to have a string for the key, which is going to be roughly a combination of the path plus the base plus the extension. So it's going to be something like, if we did this string here, it's going to be %s for the path, %s for the base, and then %s for the extension is roughly what we're going to store inside of that. And then what we're going to store inside of each of these is an integer representing either how many of them we found. If you want, so for instance, if you wanted to take 8, 9, and 10 and you wanted to rename the 1, 2, and 3, you could do that. I think for now what we're going to do is, actually we can do that, that's fine. So what we're going to store here is two things. We're going to store the highest number we've seen and the total number of them we've seen. That's still not going to work. Yeah, I think for now it makes sense just to store the highest number we've seen. That's going to be the easiest way to fix this. So in this case, it's going to become 8 of 10, 9 of 10, and 10 of 10. We could rebase them, but what makes that a little bit tricky is that, say this was 12. So rebasing them is not just as simple as figuring out the highest one we've seen and how many we've seen and sort of offsetting that. We'd actually have to go through all of them, reorganize them, and then sort of go from there, which isn't impossible. Now you got me thinking. All right, we can probably do something different with this. What we can probably do here is keep a string for the the path, and then instead of storing a total count necessarily, what we can do here is just restore a slice of strings, which will be the full paths, or we could keep a slice of files. Okay, so what we're going to say is, and I don't want this to be a variable this way, I'm going to go ahead and do to rename :equals make, and we're going to get rid of this. All right, so we've settled on this. I know that I've kind of jumped back and forth, but I think that'll be fine. So what we're first going to do is check for a match, and that's what we're doing here. That's all exactly the same. Then we're going to say if we got a match, we're going to say to rename dir. So we're going to say if okay :equals not okay. So basically, if we do not have, actually, since this is a slice, we don't have to do that. That'll be fine. So I'm going to say to rename dir is equal to append to rename with the current directory, and then we're going to append this new file, which I'm going to grab this way, and that should get it. All right, so roughly what's happening here is this to rename with the directory here, that's going to pull whatever slice is our file slice. So even if it's nil, it's going to be fine because the append function is going to handle the nil case for us. So we're going to go ahead and just say whatever's here is going to now become, this part here. So we're going to update that value. All right, looking back down the rest of this, this is probably not what we want to do. We probably want to do something like for files and each to rename. This is usually going to be keyed in the value, so the value is all we really care about. We're going to say for each file in the range of files. And then I'm going to comment all of this out. We're just going to go ahead and see, does this work? So go run main.go. Okay, so you can see here that it looks like it's working. We're getting, we have to iterate over this twice because it's a map of slices, but that's fine. But we're still getting all that. So from now, we're going to go ahead and back down here, and we're going to go ahead and try to make this code work. Or, it's going to be modified some. We're going to try to make it work. And the reason I stored this the way I did, the reason I, kept it as a map of slices or strings to slices is that now I can actually count how many files are here. I can sort that slice, based on the name here. And then once I've sorted it, I can actually, get a total count, and I can actually rename these all. Instead of using the number that's there, I can just say 1 of 3, 2 of 3, 3 of 3. So we're actually going to stop parsing the number part out of it. We're going to use it to make sure that it's a match, but we're not actually going to use the real number when we rename them. And I know this is a little bit different than the original problem we were solving, but I think this might be a little bit more handy in the sense that, let's say you pick out 10 different files and aren't going to give your client or your customer, whoever you have all these files for, all of them. It would make sense that they would only see 1 of 10, 2 of 10, because if they see 1 of 15, then 4 of 15, and the other 2 are missing, they're going to wonder what happened. Why didn't I get those files? Okay, so coming back here, what I want to do is I'm going to say for the files in the range of to rename, and then from here I'm going to say that n is going to be the length of files, and this is going to be how many files are in that slice for this particular map value. And I can also mention that up here I'm storing these files. I don't technically need to do this. I could store here just a string, and I'm actually going to show you why, and I'm actually going to make that change. So I can get rid of this, I'm pretty sure. Down here, I'm just going to go ahead and add the name. And then if I come back down here, you're going to see that, I think that's still fine. The reason this works is now I can say for each directory, and then here are all the files in that directory. So we have that information available in the map. There's no real reason to keep it in that type that we created. So n is going to be the length of the files. That's how many total files we have. Then we're going to do sort.slice. And since I'm doing sort.slice, actually I can do sort.strings. Yeah, that works. So because this is a string slice and it's not just a generic slice, I don't actually have to implement the less function. I can just pass in the files. And I think this does this inline. Let me go ahead and come here and get this. I could get it to pop up the tooltip. Might be being weird because it thinks my code is has an error in it. All right, that doesn't return anything, so it must be doing it inline. That's what I thought. Okay, so we've got the files sorted. Now that they're sorted, we're going to go ahead and say for each file in the range of files. And you need to remember here that f is going to be the file name. And then we're going to go ahead and say that our match, and there shouldn't be an error here with matching, so I'm actually going to put an underscore because we know that the only way it gets added to the slice is if there isn't an error. So for now, I'm just going to sort of ignore that. So for each match, or we'll put this in M, in match, and I could call this res for result. I think that makes a bit more sense. And we're going to pass in the file name. And then from here, we know what we want to do from this point forward is to basically go ahead and set this up. We don't even need this index, but I'm starting to wonder why I have it because I don't really need it. So we could actually pull that out if you wanted. Then I'd have to come back here, get rid of this. Actually, I'm going to keep it just in case we decide we want it. I think it's fine to leave it. All right. So I've got the result. What do I need to do in order to turn this into a new file? So what I'm going to do is I'm going to say new file name is equal to sprintf. It's going to be %s with the base. And then it's going to be a space, and then it's going to have %d, which is a number. Sorry, we want a dash here. %d of %d. Then it's going to have a period, then it's going to have the extension. So I think that's roughly how we did it before. So what are these values? The first is the res.base. The second is the index of whatever this file is. So one of the ways we can handle this is put an I here, or an fi for file index, or however you want to do it. So I'm just going to keep this as an I. But our I is going to start at 0. So what I'm going to do is I'm going to do I plus 1. Then I'm going to do n here for this one, because that's the the length of the files. And then finally, I'm going to do res.extension. And then after we have that file name, we're going to go ahead and do this line here that we had. So we're going to say, we're going to move, so we need the new path. File path.join. We're going to do directory. And then we're going to do new file name. Old path is going to be file path.join directory. And then we need the old file name, which is going to be file name. That's what this is right here. So now we can change these two to be old path, new path. And then finally we can come down here to this os.rename, copy that line, and we can even copy the errors here if we want to, or the error handling rather. It looks like we never declared an error prior to now. Oh, never mind, that might not be the issue. We need to do old path and new path. And again down here. So maybe it makes sense to put new path here as well for our errors, just so we can actually get full information. I'm going to delete all of this. Okay, so I think this is going to work. Obviously, I haven't tested it, but if this works correctly, what we're hoping for it to do, and I'm going to go ahead and just comment this out because we aren't going to use this anymore. So what I'm hoping this will do is change this to birthday 1 of 2, this to 2 of 2. These are going to become 1, 2, 3, and 4 of 4. And to actually rename this a little bit further, I'm going to name this one OSCE. So, it got removed a little bit. So this should be 1, 2, 3. And to make sure that we're doing this correctly, was 4, was 6. So I'm going to put some content inside of these so I can actually, verify them a little bit better, because right now they're all empty files. And this was 12, was 9. Okay, I think that's enough information that if one of those are wrong, we should see it. If you want, we can actually go, nested B1. I'll just go ahead and label them all. Nested B2. Nested N8. Nested N9. Nested N12. Then we've got sample B1. Sample B2. Sample B4. And finally sample B6. And we don't need to do anything down here for the Christmas ones because we're not trying to match those. If we were, we would have to split up that string a little bit differently. I'll show you I think we'll do the regex one is how we'll do it. And we'll get an idea of how that might work. But for now, we're going to go ahead and run this with just these. All right, so we got some errors. So it looks like we did something wrong. So here it looks like the issue we ran into is that So it looks like we're trying to rename sample N008. So we got the directory wrong somehow. So if we come up here, this appears to be part of our issue. Path is our issue here. So path right here is what we actually wanted to be using instead of dir. So, clearly this is one of the reasons why you want to test your programs, especially before you rename stuff. I probably should have tested that. And you're seeing here that this is actually all using 9s for some reason. So we don't really know why that happened. But I'm going to rename this 001. I'm actually going to rename all of these. I probably should have just run this as a trial run first. But I didn't because I was not being smart about it. Okay, so I think that's all of them. So I'm going to actually get rid of this part here and just go ahead and run this now. So it's looking like it's trying to rename something like this, which is not correct. So what turns out that's happening is path here includes the file name. So we need to find some way to get rid of the file name here in the path. So if we come back over here to the file path, we should be able to look here and see, is there a way to sort of figure that out? Well, it looks like this dir function might be what we want. And it says it returns all but the last element of the path, typically the path directory. So we're going to do per dir is going to be filepath.dir. Pass in the path here. And then we need to figure out, is it, oh, it's not used. That's why it's complaining. So I'm going to replace this in both of these sections where I access to rename. And now I'm going to go ahead and run this again and see what we get. Okay, so it looks like we want to rename sample001.txt to sample/birthday 104. So all of these look correct, these 4. Looking at the next 2, you'll see here that these are both 1 of 5 and 2 of 5. That doesn't seem right. So what's going on? Well, looking down here, we need to figure out, where are we getting this incorrect data from? Why is, the number we're using here not right? So we've got n here, And that appears to be coming from the length of the file, so why is that not being correct? We have 5 here. Oh, okay, I know what's going on. Or I think... Oh, okay, that makes more sense. So our problem right now is that our directory here is not keeping, the names not taking those names into account. So as a result, we're not doing the counting. We're counting all 5 of these as the same extension, when technically that's not correct. So I should have probably seen this ahead of time, but that's okay. So what we can do here is say key equals filepath.join, current directory, and then we're going to return. I'm actually going to do this inside of here if we have a match. I want to join info.name, and I'm actually going to sprintf this part. So info.name, and now we're going to actually get the matching results. So I'm going to say M here for match results, or MR for, I think M's fine for match results. I don't want info.name here. What I actually want here is m.base and m.extension. Because I know those two are going to be, it's going to be trimmed out so that, when I have birthdays, I'm going to get birthday and txt, and then for ends, I'm going to get n and txt. So let's see it probably is complaining because I'm not using key. So I'm going to do these. And then the other thing we need to remember is that down here, this is no longer a directory. This was a key. So, it's not quite the same. But we know that our keys are going to be something like sample/birthday.txt. So if we wanted to get just the path, we could actually do dir is going to be filepath.dir of the key. And we've got this dir up here. I'm actually just going to hard code it in here. And I'm just actually call it walkdir. Just because I don't want the two of those to be confused throughout the rest of this. So now it'll be dir : equals. That should change most of this. So we can go ahead and run it. All right. That appears to be working correctly. So we're looking at all this, and you see that we're still just doing a dry run, which we should have been doing from the get-go. But this is giving us birthday 1 of 2, birthday 2 of 2, and 1 of 3, and 2 of 3, 3 of 3, and we've got the same for these birthdays. So now that it looks like this all looks correct, we've got this nice dry run of what's going to happen. We can actually go run it. So that's when we go ahead and get rid of this. And even beyond that, you could actually, instead of commenting out this code, one of the things you could do is put this all behind a flag. Or is this the right code? Yeah, it is right here. You could put this all behind a flag like, real run or something like that. Something that signifies, if you don't provide this flag, we're going to assume it's a dry run. But if you provide this flag, then I'll know that you actually want to rename files. So you'd have something like flags.flag.string. And then for this one, I want this to be a Boolean. I'm not sure why I did string. All right, var dot. How do we want to do this? We'll call it wet. Why not? So I'm calling it wet because usually a dry run is, a dry run. Or actually I can just call it dry. Flag.bool var and dry. Name is dry. Default value is going to be true. And the usage is going to be whether or not this should be a real or dry run. Flag.parse. And then down here, we're going to say if not dry. Okay, so if we run this, it doesn't appear to be actually renaming files because we're still doing a dry run. If I build it, or you don't even have to build it necessarily to main.go, I can put -- help here. You'll see here that if we put -dry, it's whether or not there should be a real dry run. The default is true. All right, so we ran it, and we said dry is false. So we made sure that, I think that this makes sense in this case to make the dry run a default because this is kind of destructive behavior. It's really hard to come back from. But you'll see that some tools do it differently. You have to actually tell them it's a dry run, so it's kind of up to you. But this appears to have worked correctly. And if I go in here, this is B1, B2, this is B4, and this was B6. So they all got renamed. Same here, we've got N12, N9, and then N8, so they're in order too. And we got B2, B1, so that's in the correct order. So that appears to have renamed everything. I think that's it for this video. I know that's kind of a lot. So I think that's a good stopping point. And then the next video, we're going to do basically, it's a very small change. Essentially, we're just going to go ahead and change the way we match to use a regular expression and, not use all the other stuff. So in this last video, as I said, we're going to be using regular expressions. We're going to try to match these Christmas files, and we're going to try to rename them. Maybe, maybe we got the year wrong and we want to update that. But on top of that, we want to take these numbers and we don't want to do the renumbering type stuff we did. Instead, we want to be able to sort of use a regular expression to find, what that number might end up looking, what it might look like or whatever. So what we're going to do now is we're going to change this match. Instead of being a file name, we're going to go ahead and pass in we're going to use a regular expression. So I'm going to go ahead and say var re is going to be regexp.mustCompile. So I'm doing this, as a package level variable so that, we know whenever we go to compile and run our code that whether or not this is working. And the regular expression we want to be able to match this Christmas. But maybe we want it to be, a little bit more robust than that. For instance, maybe we have some other files that are Easter 2016. Let me go ahead and copy one of these, put it in the nested folder. Maybe we want to take Easter 26, or maybe it's 2014, 2 of 55. And maybe we want to also rename some of those. I don't really know, but that's just roughly what we're going to say we're going to be doing. And let's go ahead back here. What we want this to be is a regular expression that, so before I get into this, let me go ahead and preface this with, I'm not trying to teach you all about regular expressions. I'm going to go ahead and try to explain the one that I'm creating. But I'm just going to say that regular expressions can be confusing, especially when you aren't familiar with them or how they work. So sometimes they'll match things you didn't expect, or they won't match things you want them to. So you kind of just have to learn about them. The upside to learning them is that they generally will apply to any language. There might be subtle differences in how you construct them in different languages, but basically they're the same thing across all languages. They're just kind of a way of matching strings. So first we're going to use this, this caret that's pointing upwards. This means match the start of the string. So really what this ends up meaning is if this regular expression, like say we had the string cat in the hat, and we were trying to match in the hat for some reason, this uptick here at the start means that it would not match on the string because it's not at the very start of the string. It would start here, and if this doesn't match the end, it's no longer going to be valid. All right, so from there, we're going to put a parenthesis, which means that we're doing like a group of letters or words, whatever. And I'm going to put something like this. So dot means match any character. Star means match it as basically as many times as you can, or as many times as you really want to. And then the question mark means do this in the smallest match possible. So by default, a regular expression will try to match as many characters as it can. We're telling it to do the opposite and get the smallest match it can. So after that, we're going to put a space. We're going to do another group. So this first part is meant to capture things like Easter and Christmas. So we're just going to assume that those are all, words. And I could say family Easter is what we're going to call this, 2014. We'll call this 22 of 55. All right, so I'm gonna expand this a little bit so you can see it. I'm gonna try to make this work for that whole thing, and we're gonna see if it actually works. All right, so this should even match family Easter. Next, we want the year. So we're gonna go ahead and say this is 0 through 9, and we're probably expecting this to be 4. So that's what this 4 part is, and I think that's correct. We'll find out. All right, so then after that, we have a space, and then we have an actual parenthesis inside of our string. So rather than trying to, we can't put a parenthesis here because that defines like a group of, a grouping that we're going to have in our match. So I'm going to put a left and a right square bracket, which basically means this is a character set that you can match against. And I'm going to say the only character in that set is this left parenthesis. So that should match that left parenthesis here in these file names. Then I'm going to actually use a parenthesis here because I want this to be grouped. I'm going to say 0 through 9. And I'm going to put a plus here saying that I don't really know how many digits there's going to be, but there's going to be at least one. Then I'm going to close that group. Then I'm going to say of. Then again, same thing. 0 through 9. So this is where I'm trying to get the 100 or the 55 part. Put a plus here because there's going to be at least one digit there. And then we need to close the parenthesis after all of this. So I'll put a character set, do the closing parenthesis, and then end my character set. And then again, I'm going to do a character set with a period. So the reason I'm doing this is we saw earlier that a period matches anything in regular expression. But if I put it inside of this character set, it's going to look for that specific character, the actual period. And then finally, parenthesis, because we're going to want to group this one again. And this is going to be our extension. So what we're going to do here is we're going to say this can match anything. I'm going to put a star here. Realistically, you probably want a plus because it needs to have at least one character for the extension. And we probably could have put a plus up here because, we probably want, something up there. And then again, I'm going to put the question mark, meaning that I want this to be the smallest match possible. I don't think I need it here, but I'm going to put it because I don't think it hurts. And then at the very end, I'm putting a $sign, meaning that it needs to match the end of the string. So this is the front of the string. This means that we had to have hit the end of the string at this point when we match. All right, so let's go ahead and just see. Okay, so since that ran, that means that our regular expression is compiling. And we can move on to using it. So what we're going to do now is we're going to come down here to the match, and we need to figure out how to replace this. So we're going to say var replace string equals, and now we're going to go ahead and define how we want to replace our string. So I don't want to, I want to sort of titleize this first part, but there's no real way to do that, at least in our regex. So, how do we want to do this? Actually, I don't think titleizing it matters right now. I think that if you really wanted to do that, we could do something different. So I think that's fine. Okay, so what we're going to do here is just go ahead and use all this. And we're going to say that now we want to change our files. Now we want to rename them or reorder them in some way. So what we're probably going to want to do here is we want to do the year first. So let's look at the family Easter. The way we want to rename the file is something like 2014 family Easter 22 of 55.txt. So this is what we want the final file name to be. You can see that it's very, very similar, but it's not quite the same. And we really didn't even need this part. So maybe we want to do something like this for some reason. 22_55. I don't know. So, I don't really know which is the best, but I'm just trying to show you something that's different. We'll just leave it 22 of 55. I think that's a more realistic use. Okay, so we've got all this. It clearly seems to be working. Or, sorry, this is where we want it to be. How do we do this? Well, with a regular expression, we can actually take any of these parentheses that we're using, and we can expand them by using the match that they were. So this right here would be $1. This is $2. This right here is $3, 4, and then we have 5 back here. So this right here is coming from this one, which is $2. This is $1. This one is going to be 1, 2, 3. So it looks like 3, 4, or this is 4, and this one's 5. Okay, so that looks roughly what we want our replace string to be like. So now we're going to come down here and we're going to say old path, new path. We want to match. I think most of our code is going to be the same. Our match result is going to be a little bit different now. We're going to add something here. Actually, we're going to get rid of index. Get rid of index. I think we're going to come through here and we're going to say we're going to split it on the file name. The extension is going to come from that. We don't need any of the number stuff, which means we might have to change a couple things in our code. But that's... we'll have to change a couple things because this map isn't really necessary anymore. But that will be fine here in a second. Well, let's just do that now. So, var to rename, it's going to be a slice of... I think we're just going to put the full path. So it's going to be a slice of strings. And what we're going to go ahead and say is, here we're going to say if underscore error colon equals match info dot name errors equal to nil to rename equals append to rename, and then we're going to just put the entire path in here, and then we can deal with it from there. So this is going to become fairly different. Okay, so we've got that. We don't need most of this to be nearly as complicated as it is. So I'm just going to go ahead and comment all of this out. And we'll get back to it here in a second. Okay, so we're putting the entire full file path in here. So when we come down through here, we're going to say for each file in the range of where in to rename, we're going to say the directory is equal to filepath.dir key, and then we're going to go ahead and, we don't want key here, it's going to be F. And this right here, I'll just put path to make it clear. And then let's go to OS. And not OS, I had file path. So we have dir. Let's see if, and I should also mention that while we're here, you can see there are some functions here like ext, which will try to get you the extension of the file you're using. So when we wrote our first version, we could have actually changed some of that stuff, but we're going to go ahead and let this go. So I'm looking for something here. It's going to give me something close to a file or a file name, something along those lines. I don't know if it's going to be, let's see. All right, base returns the last element of the path. All right, so it looks like base might be close to what we want. So let's go ahead and give it a go. So file name is going to be filepath.base with the path. And then we're going to go ahead and say match. So new file name, and we'll ignore the error here, are going to be match file name. Then we're going to go ahead and put this whole section here. Comment this out, bring it back. So we're going to say path is going to be, I can actually make this old path because that's actually what this is. And then new path is going to be filepath.join dir with the new file name. And this is match result right now, which is not what we're actually going to be returning here. We're going to return a string here, which actually represents the new file name. We're going to go back to the way we used to be with that, because I think that makes the most sense. So this is going to be returning the empty string, and this is going to need to be implemented to do and nil. And a lot of this is going to need to do. Okay, so I think this is all correct. Assuming I got this all right. I'm going back down through here, delete all this. We've still got the dry run stuff in place. So now what we want to do is we want to come down here to our match, and we want to make it use these two things. We want to make it use the regular expression and the replace string. So what we're going to do down here is, we're going to say if, how do we want to do this? So let me go look at the irregular expression. It's not what I want. This is what I want. I'm going to go to the index. I'm going to try to look through here. I'm pretty sure I can use something like replace all string, and I think this will do what I want. Yeah, so when you're looking at this, it will replace all the strings with this, but it doesn't really tell you if it matches it. So we need two things here. We need a match, and match string is probably what we want. So match string reports whether the regular expression matches the string S. So we're going to go here, and we're going to say if re.match file name. Actually, we're going to change that. If it doesn't match, return empty string and then this part here. All right, so we get that base case out of the name or out of the way right away and figure out why. Oh, match string is what I wanted. Okay, so at this point we can assume there's a match. So now we just need to replace the match with that replacement string, and we can then return that. So I'm going to return re.replace all string, which is going to take in the source, which is the file name, and the replacement is going to be replace string, and then we're going to return nil for the error. And you'll see here that in this case, this function got much, much simpler. But again, we're using a regular expression. That's up here, and you can see that this is also obviously not much simpler. This is a fairly complex thing in comparison. So our code looks simpler, but realistically, I would say it's more confusing because now you have to understand regular expressions to really know what's going on, and this is just not clear to read. Okay, now that appears to all be there, let's do a dry run. So it looks like we're going to rename sample Christmas 2016 1 of 100 to 2016 Christmas 1 of 100. So all of these look right. Let's look at this last one. Sample nested family Easter 2014 is going to become sample nested 2014 family Easter 22 of 55.txt. That all looks right. So we're going to go ahead and run it with try equals false. All right, coming back here. Looks like it worked. All the files are renamed. I think that's what we wanted. All right, so you can see here that if you wanted to make something really generic, one of the ways you could probably try to do it is let the user provide you with this regular expression. Obviously, it wouldn't be able to be a global variable here that we compile at this point. We'd have to compile it, when our program runs. But, we could do that. And then on top of that, we would need to have them provide us with a replacement string that uses things from it. Now, that doesn't give us a ton of flexibility in the sense that we can't titleize things like we were doing before, but it would allow us to, at least do some rearranging of the data. We could even drop some of the data. For instance, if you didn't care about the of part, you could do something like this, where you're only matching certain things you care about or setting the things you care about. So you've got some options there. I'm going to go ahead and just let this be for now, and that'll, that gives you an idea of how to use the regular expressions to do this. It should also give you an idea of if you want to try to build something more generic, how to go about doing that.